Hello everyone, my name is Ken Petroff. I'm the product manager for the Transformer products out of Valley Forge, Pennsylvania for Megger. Here today I'm going to talk about the true three-phase Transformer Turns Ratiometer, the TTRU3, and I'll be going over the quick test, magnetic balance, and test plan today. First, we're looking at the quick start guide that is included with every true three-phase TTR. We are going to make our connections based on the connection diagram that you see in the middle here. Always start with your ground connection first, followed by your connection to the true three-phase TTR. Here we have our primary leads in red, our secondary leads in black. You'll also notice that the connectors are color-coded: silver for connecting to H and black for connecting to X. If we follow the lead sets, we are connected to our transformer that we have in our AVO lab. For those of you who have taken classes in Valley Forge, Pennsylvania, this will be familiar to you. You'll see that our clamps are also color-coded by phase. So we have red for H1, yellow for H2, blue for H3. And likewise, on the secondary side, we have red, yellow, and blue, and also white for neutral. And since this is a DY11, we simply leave the neutral disconnected on the primary side. For this video, I am going to be operating the TTRU3 from my PC for ease of recording. But first, I'm going to connect my USB cable to the top panel of the true three-phase TTR. So right back here. And what you'll notice on screen after I connect this is a USB CD drive will pop up. And this contains the PC application that you can install to control the device. It also contains all of the user guides in the various languages, the data sheets, and any application notes. So whenever you have the true three-phase TTR, you don't have to go online to get the latest user guide. It will always be with the instrument. For my purposes, I have already installed the true three-phase application, which is running right here. I'll go ahead and maximize this. And if you take a look at the user interface that comes standard on all the true three-phase TTRs, you will see that it is identical to the PC application. So you only have to learn one application to use this device. I'm going to start with the quick test today, and if we look at the nameplate here, we see that we're working with a DYN. So what I'm going to do here is select quick test, and I'm going to match up my vectors on screen to the vector that is on the nameplate. We can do that here very easily by taking a look closely at the nameplate here. We see that we have the D with the H1 in the bottom left-hand corner. So if I look at my primary diagrams, I see that I have the D with the H1 in the lower left-hand corner here. The next thing I'm going to do is select my secondary vector group. My secondary vector group is a YN because on my vector here I have a neutral. So I'm going to select YN. And then I need to select the correct phasing. Here again, I'm going to compare what the vector looks like on the nameplate. We'll see we have X1 that's pointed at the 9 o'clock direction. And we see here that that corresponds to YN1 over here. Alternatively, you can go and select your secondary vector group again. And then over here we have the find vector function. And if you click that, the transformer test set will be energized, and it will automatically detect the vector group for you. And there we see that it found the DYN1. So I know that I have my leads connected correctly. So after selecting my vector, I don't need to do anything else. I can simply click the test button. Since I did not enter a test ID, it offers up a default test ID based on date and time, but I'm going to go ahead and change that to the AVO transformer, accept, and then I will start the test. So after a few brief seconds, the testing will complete. Since I did not enter in any nameplate taps or voltages, you'll see that I just have my turns ratio result here. And I don't know if that's within percent error or not. So if I go back to my test setup, what I can do here is I can enter in my nameplate voltages. And I know that on this particular transformer I'm on tap 1. So my voltage is going to be 4805. I'll take that and enter 4805 here. And then I know that my secondary is 230 volts. So I'm going to go ahead and enter 230 and then start the test again. So now we see we get our percent error right over here. And if it were to exceed this limit of 0.5, it would be highlighted in red. For those who want to view this in TTR ratio, you can go ahead and change that ratio display right up here in the corner. If you're not happy with the results, you can always retest. But these look pretty good, so we'll go ahead and save. So that's it for quick test. It's very flexible. It allows you to put in as little or as much information as you want. We're going to move right along, go over to the home here, and we're going to do a magnetic balance test. The magnetic balance test is very similar to the quick test. When we go inside, we'll see that it uses the exact same setup. Really the only indication that you're doing a magnetic balance test is the symbol in the near the test button here. So let's go ahead and run this magnetic balance test. Now the magnetic balance test will take a little bit longer. In addition to providing the turns ratio result, it will provide magnetic balance by exciting each leg of the transformer independently. And it does that by exciting the YN leg here for this particular vector diagram. So in the results, what we see here along the left-hand side is the excited phase. So it goes through and it excites each phase individually, so X1, X0, X2, X0, X3, X0. And when it excites each one of those legs, it's going to measure the induced voltage on the corresponding leg. So here, X1, X0, the percent induced is 100%, while X2, X0, we're seeing 75.8%. and X3, X0, we're seeing 25.2%. This is what we refer to as the table view. What we can do up here in the left-hand corner is change our view to a table. And with magnetic balance, you're looking for this nice balance between the legs that were not excited. For example, in the middle here, they're very well balanced. This test is primarily used during transformer manufacture. It's very popular in India. But it can be useful if you're looking for a little bit more information about your transformer. Changing the view one more time allows us to see the turns ratio result. So again, you're getting both results at the same time with magnetic balance. No need to run two separate tests. This result looks good as well, so we're going to go ahead and save it. The test plan is this in the bottom left-hand corner here. You'll click on test plan and you'll see that we have a bit more information than what we had in the quick test. You'll see that you have your vectors and then you can select tap changer for each one of the windings. And this is a 2-winding transformer. It does not have an OLTC. It has a de-energized tap changer on the primary, and on the secondary it technically has a DETC but only with 1 tap. So we're going to go ahead and change the number of taps to 1. And there is really no tap labels, so we'll just go ahead and leave it as 1, 2, 3. For this transformer, the nameplate is listed as taps 1, 2, 3, 4, and 5. So here we see that we have the tap labels 1, 2, 3. The number of taps is 5. If we look at the nameplate here, we can confirm that. The nominal tap is tap number 3, where we would see 100% of the voltage. And then it comes to actually entering in the nameplate voltages. The nominal tap and the nominal voltage is what we will enter first. So the nominal voltage here, if we look at the line to line, is going to be 4586. So we will enter 4586. The first tap is 4805. So we're going to enter 4805. And the last tap is going to be 4356. And just like on the other test, the secondary will be 230 volts. So now that we've entered the nameplate information required to run the turns ratio tests, along the bottom here we're going to look at the calculated tap voltages. And we'll see here that we entered the first tap voltage of 4805. Our nominal tap voltage of 3 was 4586. So this middle one here, if we look at our nameplate here, it says 4700. Looks off a little bit, so we can go ahead and adjust that. 4700. We will scroll down and look at tap 447, or tap 4, which is 4471, which matches there. And finally 4356, which also matches. Secondary, we only have the 1 voltage there, so we would expect that to be correct. And then we come to the asset info along the bottom. This is nameplate information that is not required for turns ratio testing, but does allow you to build out your full report. If so desired, you can fill that out. Here we have the nameplate of this particular transformer. But for the purposes of this testing, I just want to show that it is available there to enter the asset ID, the manufacturer, serial number, etc. But we will go ahead and just skip over this for now. The test conditions, the tester, either the person or the company doing the testing. The reason for the testing, what the weather was like, the ambient temperature, humidity, and oil temperature of the transformer. Again, these are settings that are not required to run the turns ratio test, but allow you to fill out that complete test report. Finally, we're going to go to the test setup. This brings us to a screen very similar to the quick test, where again we are going to go ahead and select which tap we want to test. The way that I have this configured right now is that we are on tap number 1, and there's only 1 tap on the secondary, and we're going to go ahead and run the test. Again, it's going to ask me if I want to use the default test ID, but I'm going to say no, and I'm going to enter the AVO TX test plan and save, and then I will start the test. So very fast, just like the quick test. Again, you can look at the TNR, TTR. But now that we're done with this test and we want to go and test the next tap, you could go back to the test setup and return to that previous screen, or you can simply use this button up in the header to change the next tap and run the next test. And here again, we see that our results come in very good. And like the magnetic balance test, we have this view button in the top left-hand corner. This will allow us to look at a graph view of the percent error as we do our testing. Or we can look at a summary of the results. So we have 2 tests completed so far, no errors, nothing exceeding the percent error limit. So I will go back to the turns ratio view and change the tap down to 3, change the tap, and do the next test. And there we go. So if we change our view again to look at the percent error, we can see the nice graph that we have built out with the 0.5% error limit here and minus 0.5% error limit on the bottom. Everything is within range. We can change our view if we want to look at all of the phases, an individual phase. Very useful if you have 1 tap that's going out. Here is our view of the summary of results, where we have our date and time, the vector, the number of results, the voltage and the mode that we were testing. Since we're done with this test, if I want to keep it for my records, I'm going to click Export. And here it will tell you where this is exported to. So if I go to that location in my documents, and then I'm looking for that date time stamp from today. And if I go into my test plan results, I will see my Plan AVO TX test plan. I get this in both an Excel and PDF, but it contains the same information. On here we'll see the serial number of the TTR, the tester, all of this nameplate information that had I entered it in, would it have been populated, the vector that we used, the percent error, and all of the results for the 5 taps that we listed, and the graph. This export you will get the same whether used from the PC or from the 7-inch display itself. Close that out here. Confirm that the export was complete. When you return to the home screen, you'll see that next to the test plan there's a continue button. So let's say that you left for lunch or you needed to come back and you wanted to finish your testing. You can quickly click on that and it will bring you right back to this test setup where you can either continue your testing or view the results for the testing that you just completed. If you wanted to, let's say you had a lot of results, you could go to the results button over here along the right hand side, click results, and you can see that we have 3 results here. The first one is the turns ratio test, that quick test that we did at the beginning. Here is the magnetic balance test, and then finally followed by the test plan. We give you a few different sorting options over here. You can sort by the ID, you can sort by the date tested, you can sort by the vector, and you can sort by the number of results, either up or down. Exporting from here will export all the results and not just the test plan result that we were just working on. Return home. I'm going over a few of the settings now. Here we have our measurement and limit settings. Here you can tell the line frequency that you're testing at or that you're using to power the device rather. The test buzzer, either on or off. This was that test countdown that we saw at the beginning of each test. I'll recommend leaving that on for safety reasons. Imbalance limit, this is a magnetic balance setting. Ratio display, you can choose your default here, either TNR or TTR. Ratio error limit, plus or minus 0.05% is, or plus or minus 0.5% rather, is what's in the standards. Phase deviation limit, we have it defaulting to 0.5 degrees. You can also choose your phase display, whether you want to see it in minutes, degrees, or milliseconds. I prefer to leave that as degrees for myself. Error limited OLTC, this is for the automatic OLTC function that is present in the some of the models. And then finally auto continue. Auto continue, if you were to power the device off and then power it back on, it's sort of like this continue button that's down here. Rather than having to come to the home screen and click on the continue button, it will automatically bring you back to this screen so that way you can finish the testing that you had previously started. Going back into the settings, you can set up a default transformer nameplate. So let's say you test DYN11s all the time that have the same 5-tap DETC and 33-tap OLTC. You can configure that here. You can round the tap voltage calculations either to 1, 5, or 10 volts. Choose the standard that you're working in. Megger is a worldwide company, so what you test in ANSI, IEC, or the Australian standard, typically you set that once and then forget it. Tap phase shift for your phase shifting transformers. You can configure the number of OLTC nominals you would like to see in the nameplate if there are multiple nominals. And then finally, relative phase shift, either on or off. That is for the phase shifting feature. And the relative phase shift is phase shift from a specific vector, while absolute phase shift is the phase shift from 0 degrees. Of course, we have some regional settings. You can change your number format. You can change your date format. Date and time on the PC is controlled by the PC, so that will do nothing. But then we have our standard languages: English, German, Spanish, French. We have Korean, Chinese simplified, and Chinese traditional, Vietnamese, Portuguese, Ukrainian, and Russian. The OLTC control is for the auto OLTC functionality. You have two options for the OLTC control, either manual or auto. There will be another video detailing how to use this. Then finally we have a few administrative features. The password you will find in the user guide, where you can restore some factory settings, or you can configure your export folder. By default, it goes to the username, then My Documents, and then the Megger folder. But if you want these to automatically export to your network drive, you can go ahead and set that up. And for those who do not want the USB thumb drive to show up, you have to go to the device itself and turn that off if you need that turned off for safety reasons. The About screen in the bottom right-hand corner. This will tell you what model of TTRU3 you have, what software version you are running. For more information, you can click on Detail System Info. This will tell you which of the features you have enabled or not, and some low-level software and hardware information. And then finally, you have the Check for Updates. On the PC, it will instruct you to go to Megger.com/TTRU3, and you will be able to look for any of the latest updates there. You will simply reference the version that you have here and see if there is a newer one available on the software tab here. Alright, and that wraps up the TTRU3 and using the quick test magnetic balance and test plan functionality. My name is Ken Petroff. If you have any questions, my email is ken.petroff@megger.com. Thank you.